This is the lesson for Mod 9, Lesson 7a, Trigonometric Ratios. All right, the goal of this section is going to be to identify trig ratios for a right triangle. So a good question that comes up is, why do we learn this? Because it looks like we're just writing a bunch of fractions. The purpose of why we learn this is, if I was to give you a triangle, let's say something that looks like this, where I have a 50-degree angle, and let's say this was 10 and this was x, for example. So far we've learned a couple different methods. We've learned Pythagorean theorem. In this case, you can see Pythagorean theorem wouldn't work. We only have one side given to us. We've also learned special right triangles. So we've learned 45, 45, 90 triangles. We've learned 30, 60, 90 triangles. And this 50-degree angle, the other one would be 40. We haven't learned how to solve triangles that have angles that are not one of the special right triangle angles, right? So right now, this is not a problem we know how to solve yet. What we're going to use is trigonometry, or trig, to solve this problem. So that's where this is going. So in this lesson, we're just doing a bunch of fractions. The next lessons, we're going to use those fractions to actually solve a problem like this, where we have to use trig or something different to find the missing side. Okay, so the three ratios we're going to talk about are sine, cosine, and tangent. And these are actually just relationships within a right triangle. So these, a lot of times, we treat as like a ratio or a function. So you're going to find that we use abbreviations. So sine, we abbreviate with SIN. Cosine with COS, and tangent with TAN. We always have it evaluating an angle, so you're never just going to see the word sine with just equaling something. That won't really make any sense. It's always going to be in relation to an angle. So in this example, we're using angle A in this triangle. And when we talk about sine, cosine, and tangent, we're going to be looking at, for this mod, acute angles. So the angles that are less than 90. So we're not going to be doing this for our right angle. In this example, it would be for like angle A and angle B. So sine, cosine, and tangent is just a relationship of the different sides. And so part of it is just knowing how to name it. The hypotenuse is what we're kind of used to. So it's opposite the right angle. We then pick one of the acute angles, and we have to name the two legs in relation to that angle. So we can't just say the legs, we got to give its location. So the leg that is next to the angle is the adjacent leg, and the leg that is across is the opposite leg, right? And opposite meaning not opposite sign, but opposite in terms of location. It's across from that angle we're looking at. So we're going to write a series of fractions when we have these values. Sine is going to be the opposite leg over the length of the hypotenuse. So it's just going to be a fraction. Cosine is going to be adjacent over hypotenuse. And tangent is opposite over adjacent. So we like to remember an acronym here, SOHCAHTOA or SOHCAHTOA, however you want to remember it. So that's usually an acronym we use to remember. So sine, you can see, is opposite over hypotenuse, so that's where the O and the H come from. Cosine is adjacent over hypotenuse, so that's where the A and the H come from. And tangent is opposite over adjacent. So we like to use those first letters to remember the relationship for sine, cosine, and tangent. And today we're just going to be writing a series of fractions or ratios that we're eventually going to use to solve. So for the first examples, notice the directions just say write the trig ratios for each acute angle. So that's each angle that's less than 90 degrees. So the non-right angles in the triangle. And then write your answer in simplified radical form, and you rationalize. So we don't want any decimals, any radicals that are in the denominator. All of our answers should be fractions, and they should all be rationalized. So for example 1, you're going to see, even though these look like the same problem, this is actually two different problems. So one is asking for sine, cosine, and tangent for angle A, and the other one's asking for angle C. So we're going to start with just angle A. So if I look at angle A, all right, we're going to go ahead and label everything out. So across from the right angle, you can see that's my hypotenuse. I'm going to put H for hypotenuse. Opposite and adjacent is usually where most students get confused. So if I go ahead and trace the angle, that's probably the easiest way if I'm talking about angle A. The leg that I use that forms that angle, that's always your adjacent leg. So that means next to. That's actually what adjacent means. And the leg that's across is your opposite leg. Or I'm going to put OPP for opposite. So when we write this out, our hypotenuse is identified the same way. The leg that helps form that angle is the adjacent leg, and the leg that's across is your opposite. So I'm going to write my acronym at the top. That's pretty much what we're going to use for the next couple sections anyway. So SOHCAHTOA, so I mean sine, cosine, and tangent. So if I'm looking for sine of A, I'm going to see that sine is opposite over hypotenuse. So opposite over hypotenuse. So my opposite is 10. My hypotenuse is 26. And then I'm going to go ahead and reduce that. That reduces to 5 over 13. So what I'm saying is the sine of angle A is 5 over 13. I'm now going to do the same for cosine. So cosine is 24 for adjacent and hypotenuse, because C and A. So 24 over 26. And cosine of A is going to be the ratio of 12 over 13. And then finally, the last one, tangent, is opposite over adjacent. So my opposite is 10. My adjacent is 24. So 10 over 24 is 5 over 12. For sine, cosine, and tangent of C, you're going to find it's actually very similar, except instead of revolving everything around angle A, for C, we just revolve everything around angle C, right? So if I go ahead and I'm going to erase maybe some of these, the hypotenuse is going to stay the same. But if I do the same for C, and I trace it out, this is going to be my adjacent leg, and this is now going to be my opposite. So when we go ahead and write this out, my sine is opposite over hypotenuse. So that's going to be 24 over 36. Or 26. 12 over 13. Cosine adjacent over hypotenuse is 10 over 26 or 5 over 13. And then tangent is 24 over 10. Or 12 over 5. So it's not a coincidence that the ratios kind of appear twice, because you're working with the same triangle, right? So that's why that happened. For the second example, it's kind of the same thing. The only thing that's a little different is you don't have all three sides. So if I needed to find, I have this as 5 and 3 and 5, I might have to do Pythagorean theorem to get my hypotenuse, and that's okay. So 3 squared plus 5 squared, and then I would go ahead and solve. So sometimes you might have to do Pythagorean theorem, which is something we have already covered. We would get root 34. And so we're going to go ahead now and do the trig that we normally would, like the setting up the ratios. So angle D, if I was to trace it out, so this is my hypotenuse, this is my opposite, this is my adjacent, and then we just write it out. So this would be 5 over root 34. And then when we rationalize it, because we can't have a radical on the bottom, it actually ends up being 5 root 34 over 34. Because again, you're going to rationalize that out like we saw in some of the other videos. For cosine, that's going to be 3 over root 34. Or 3 root 34 over 34. And then for tangent, that's going to be 5 over 3. For sine of f, you're going to find, again, it's the same thing, except the only difference is you kind of interchange those ratios. So sine of f, it really ends up being the same as the cosine of d, right? So we end up getting 3 root 34 over 34, 5 root 34 over 34, and 3 over 5. And again, same process as before. In these last two examples, it's the same thing. This kind of is going to lead to what we're going to do in the next couple of sections. If I have a special right triangle, I could still do sine, cosine, and tangent, right? So SOHCAHTOA. I'm going to write at the top. I always want to write it when I have all three sides, if I'm going to write all three ratios. So this first one is a 45, 45, 90. So I know that if the leg is 5, the other leg is 5, and the hypotenuse is 5 root 2. And so if I want to find sine of 45 degrees, I can use any of the 45. They're the same angle, basically treated the same way. So this would be my opposite. This would be my adjacent. This would be my hypotenuse. And then I would do the same process. It's just instead of calling it F, I'm calling it 45 degrees because I actually know what the value is. So sine of 45, that's evaluating the angle. The opposite sign is opposite over hypotenuse, so that would be 5 over 5 radical 2. I can simplify the 5s, and I get 1 over radical 2, and then I have to rationalize it. And you won't have to do this for every problem. You'll see this one comes up a lot, actually. So root 2 over 2 would be sine of 45. Cosine is also 5 over 5 root 2. So I just get root 2 over 2 because I just did that problem. It's the same thing. So sine and cosine end up being the same. And then tangent is 5 over 5, which is 1. So tangent of 45 degrees is 1. For the other problem, it's basically the same thing. So if we go ahead and write it out, so the leg next to the shorter leg, this is a 30, 60, 90. The hypotenuse is going to be 6, and this would be 3 radical 3. So if I had to solve it out, I could. And then you would just basically do the same thing. So I'm going to use the 30-degree angle first. So this is my opposite, my adjacent, and my hypotenuse. And then I just go ahead and write this out. So my sine would be 3 over 6. Which is 1/2. Cosine would be 3 radical 3 over 6. And then I can reduce and get root 3 over 2. And then tangent would be 3 over 3 radical 3. Which is, if I reduce, 1 over radical 3. Or if I rationalize it, I would get root 3 over 3. For the last piece, for 60, it would be almost the same thing. We just kind of interchange those out. And then, again, you might just find that the sine of 60 is the same as the cosine of 30. And vice versa. And then this is, like we saw already, is really just the reciprocal, right? If I flip it. So root 3 over 3 and you get radical 3.
If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.